Let's talk about angle x and angle minus x and how they're related, okay? Or more like how their trigonometric functions are related. So let's assume as before that our angle x is between 0 and 90 degrees. In this case, angle x is going to be plotted in counterclock direction. So point A is going to correspond to angle x. Now, if we go from horizontal axis and go clockwise, going down angle x, we're going to get the point B, and that point is correspond to angle minus x. Okay? So coordinates of point A are going to be cosine x and sine x. Coordinates of point B are going to be cosine of minus x, sine of minus x. Okay? Now, what we're going to do, we're going to connect point A and point B, and it turned out that that line is actually goes at 90 degrees to the horizontal axis. All right? So what happens here is, well, obviously you can trust me that that's the case. If you don't want to trust me, in this case, it can be easily obtained. So to do that, let's just assume that we're going to draw one line from point A down at 90 degrees to the horizontal axis. And we're going to get another line going up from point B at 90 degrees to horizontal axis. Now, we're not going to assume that they're going to come at the same point. We're not going to assume it's just one and the other line are just basically the same line. No, we're not going to do it. But what we're going to do, we're going to consider the top triangle and the bottom triangle, okay? Now, I've shown that point as point C, assuming there's one point, but at this point, we don't have to make this assumption. We assume that we have some triangle, right triangle on the top, and some right triangle on the bottom, okay? Now, both of these triangles have, well, angle D, same measure, it's x. Also, we have one angle, another angle, around C here, that those angles are at 90 degrees both. And we also have that length of hypotenuse DB equals to the length of hypotenuse AD. They're both equal to 1. Okay? So what we have now, we have two triangles on the top and on the bottom. They're congruent because they have two angles and one side that are congruent. And because of the congruency of those triangles, we know that corresponding sides are going to be congruent. So the horizontal leg for both triangles have to be the same. It means that the point C is the same point for both triangles. And we can also say that AC is going to be equal to BC for the same, because they're congruent triangles. That's one way to look at it. Now, if you don't want to deal with congruent triangles, that's fine. We can look at a different way. If you look at the right triangle, if you remember the definition of sines and cosines through the right triangles, you would know that DC have to be cosine x for both triangles, right? So I'm saying that the horizontal, I guess it's not exactly correct to say DC equals cosine x because we don't have point C yet. We didn't establish that that's the same point for both triangles. But what it tells us that the horizontal leg, horizontal side of both triangles is of the same length, cosine x, and therefore point C is the same point for both triangles. Okay? And also, from the definition of sine for the right triangles, we know that AC equals to BC and equals to sine. Now, if we look at the horizontal coordinate of point A and point B, we see that it's supposed to be the same. Okay, it's the distance DC which means that cosine of minus x, horizontal coordinate of point B, should be equal to horizontal coordinate of point A. Now, vertical coordinate, on the other hand, they lay the same distance from the horizontal axis, because AC equals to BC, but they lay in opposite directions. And because of that, they have this, they equal in magnitude, but the opposite in sign. So sine of minus x is equal to minus sine x, okay? So what we see here is that cosine doesn't care, really, whether x is positive or negative, okay? Cosine of x, cosine of minus x, doesn't matter. Such functions that don't care whether you put x or minus x, they give you the same answer. Such functions called even functions. So f, if you have even function f of minus x equals f of x. That's the definition of even function. So cosine is an even function. The other functions that are even are like power functions with even power, like x squared, x to the 4th power, x to the 6th power, x to the 8th power, and so on. Now, sine, on the other hand, does care about sine of x. In fact, it cares in a certain way. Sine of minus x equals to minus sine of x. So functions like that, like when f of minus x equals to minus f of x, called odd functions. And sine is an odd function. Other functions that are odd are power functions with odd power, like x, x cubed, x to the 5th, x to the 7th, and so on.